Hello. So here we are quickly reviewing some basic techniques to find out electric fields of charge distributions, and I will eventually talk about one of the homework problems that you have, which is chapter 23, number 39. But before we go into that specific problem, I will just briefly describe like what you need to do to start a problem like that, just to know how to set it up. Okay, so in most of these problems, and eventually in chapter 24, you're going to see like whenever you are asked to find out electric field, which is E, right? You will need several things. You will need to know um, charge distribution, the geometry of charge distribution, right? So if you have, for example, two of the charges like Q1 and Q2, and if you want to find out the electric field at a point here, right? So all you have to do is to know what are the charges, which you already know, Q1 and Q2, and you will also have to know how are or how much is the distance between your source charge and the probe point. Okay, so this is the field point. Sometimes P is called the field point, and you will need to know the distance R1 from Q1 to P, and then you will also need to know R2 from Q2 to P, because you will basically be finding out electric field for Q1, and you will call it E1, and then you will find out electric field for the point Q2, and you will call it E2, and then you will resolve or you will express E1 and E2 in your standard X and Y axis with their unit vectors, right? And once you do that, and you will have to basically do this with respect to an angle. So if your E1 is like this and your E2 is like that, you will need to know these angles, right? This is theta 1, let's call it theta 2, and this is E2 basically. Right, so in each of these cases you can write down E1 as E1x cosine theta 1 I hat plus E1y, actually I would just call it, sorry, I would just call it E1 cosine theta 1 to make it simple, because E1x itself is E1 cos theta 1. Alright, so E1, sorry, sine theta 1 j hat, and the way they're directed is like this. So E1, which is this guy, has E1 sine theta 1 along this direction, along y, and E1 also has E1 cosine theta 1 along this direction, right? Similarly, the E2 has a y component like this along y, and you will call it E2, sorry, cosine theta 2 I hat plus E2 sine theta 2 j hat. And now you have basically expressed both of these two vectors in terms of i's and j's, and you know that when you are adding these two guys, E1 plus E2, will be very easy to now just add the I components to the J components, right? And so that's basically how you're going to approach each of these problems. You're going to express E1 in terms of I's and J's, E2 is in terms of I's and J's, and then you are going to add them so that your final result will look like E1 cosine theta 1 plus E2 cosine theta 2 times I hat plus a similar term with j hat. You will have e1 sine theta 1 plus e2 sine theta 2. I'm just skipping writing all that thing because I don't have that much space here. The point is, if you have many such fields, right, if you have now 1 e1, you have 2 e2, and then you have 3 e3, and so on and so forth, right? If you have 5 of these, you can still follow the same protocol, you can still follow the same rule and use the same method to add all of them to find the net electric field. Now let's come back to problem number 39, where you are given a charge distribution like a dipole, but it's not exactly a dipole, it's not same charges. One of them is minus 2q, sorry, plus 2q, another of them is minus q, and you are trying to find out electric field at a point here. This is A, this is 2A, similarly this is A and 2A. I mean, skipping the details, what we need to know here is that you have two electric fields, right? One for the positive charge, and we are going to call it E plus. You can call it E1 if you name this guy to be Q1, but I think E plus is a much easier nomenclature. And you know that when you have a positive charge here, and if you want to try to find out, if you want to find the field at this point, if your field point is at 2A, basically meaning that your electric field is going away from it. So you join these two lines and you put, an electric field going away from it. Then you have a minus q charge, right? So you will have another electric field working here, and I'm going to use green line so that now this is a negative charge. So if you are trying to find out electric field here, you will imagine that you are going to put a +1 coulomb charge at the field point, and that will basically give you an attractive force. Right, so this is your second electric field, and let's call it U2. Okay, so your job in this problem is to find out the net result of E plus and E minus. Sorry, that should be E minus. Our nomenclature should be that way. So we should be just finding out E plus E minus, and just like before, what we can do here is we can find out E plus cosine theta 1 or theta plus, right, and add them with E minus cosine theta minus, imagining that this is theta plus, and you can say this is theta minus. In order to do this, you can see that you will now have to be careful regarding the signs, right? So this is positive y-axis, this is your E plus y, E plus sine theta plus, and this is E plus cosine theta plus. Similarly, your green line will have E minus sine, if this is your theta minus, E minus sine theta minus, and then you have also along x-axis E minus cosine theta minus. So your E plus sine theta plus and E minus sine theta minus are directed opposite to each other. So for the sine component, you will subtract them. For the cosine components, you're going to add them. They're reinforcing each other. And you are going to express them with I hat and j hat as we have done always. So this should be your final result, a net electric field at that point. Um, and this is just for the first problem. This is the first point one. This is the point one, the first of the four. So you will need to do this for 1, for 2, for 3, and for 4. Some of them will be very easy because, as you can see, um, if you are trying to find out electric fields here or here, it's just like on this line. You don't have to work with angles. Just subtraction and addition will work. Or only at points like this and this, you will need to work with um, angles, where you will have to actually find out these lengths and these angles. Okay, so I hope this is some help for solving problem number 39. I also have a hint page for problem number 39 uploaded in Canvas. So I guess by looking at this video and then looking at also the same hint page again, you should be able to solve it. You should be able to find like 4 different electric fields, net electric fields, and you will be able to be calling them E1, E2, E3, and E4. So there are like 4 different answers you are expecting, corresponding to 4 different points. And here I have just shown you how to solve it for number 1, how to solve it for the point number 1, which is a 2a distance from origin along the y. Okay, so I'm stopping here now. And we'll be back with more like similar mini lectures on problems that you are solving. Goodbye.